In the article Agassi wins again, the author describes how skill differences work in different types of sports. In team sports, skill differences don't matter greatly, so worse teams, such as Team Sphere, can win against clearly superior teams like Team League. However, if I was to play tennis as an individual sport against Andre Agassi, it is very unlikely that I would ever win. Skill differences are amplified in individual sports. In the article Agassi wins again, the concept of binomial probability is referenced. In a binomial experiment, there are two mutually exclusive outcomes, often referred to as success and failure. Along with success and failure, there are several more conditions to satisfy in a binomial experiment. First of all, there has to be a set number of trials. In the context of tennis and Agassi, this asks the question of how many rounds, games, or sets are we playing. Also, there must be independence in and between trials. Outcomes of one tennis round does not affect another round. Probability of success must be the same in all trials. In other words, my chances of beating Agassi in one tennis round are the same for all tennis rounds that we play. However, this does not take into account factors such as serving advantages, which do slightly change the probabilities of success. Along with these conditions, there is a formula to calculate binomial probability. N is the number of trials, in other words, the number of rounds that you play. R is the number of successes, the number of rounds that I win. P is the probability of success, and Q is the probability of not success or failure.
One example of this concept is called the gambler's ruin. Imagine you are flipping a biased coin against an opponent. In order to win the game, you must get 10 points. Your chances of winning a coin flip, therefore getting a point, is 25%. If you wanted to find the probability of you winning 2 points before your opponent, you would first find all three possible outcomes. The first outcome is winning 2 games in a row. The second outcome is winning the first game, losing the second, and then winning the third. The last outcome is losing the first game and winning 2 more games. The overall probability is 0.156. You could also try calculating winning 3 points before your opponent. The overall probability is 0.104. Therefore, the overall probability of getting a victory is less than 1%. Your best bet will be to use one toss to determine your overall victory. That means that your probability of a victory would become 25%. Hey.
Hey, Wendy.
Where are you going?
Home. That's my truck.
I see. So, do you know what we're going to do for the skit for the math project? How about when are we going to meet up?
Pineapple.